Okay, so now we jump to the third section, which is understanding rainfall for flood modeling. In this section, we will discuss more, and you guys will be introduced on how to calculate the rainfall design on estimate the rainfall intensity. So you guys will be introduced to the frequency analysis and also return periods, and then we will discuss about the PMP, probable maximum precipitations. So why we need to analyze rainfall? Kalau you dengar saya punya section tadi, kita banyak discuss on how we estimate the rainfall, what the impact of the climate change to the rainfall. So, and then we have learned about the water cycle. If you disturb the water cycle, especially when there is an effect of the climate change, the rainfall. So normally it will disturb all the component in the water cycle. So hujan actually is very crucial when we want to analysis anything related to the hydrological response. Hydrological response is like, you want to study the floods, you want to study the water inflow, water supply, and etc. That's the reason why we need to analyze the rainfall. So before we go through on the rainfall estimations, so this is the framework that you guys can be used to produce the risk map. The first thing you need to really understand about the rainfall. So how we design the rainfall. We have a frequency analysis, you have the IDFA curve, and then you have ARI, average recurrent interval or return periods. And then that data, which is rainfall, will become an input to your hydrological modeling and also the hydrodynamical modelings. So hydrological and hydrodynamical modeling, sometimes we call as a flood modeling. I do not like to use term flood modeling because the hydrological and the hydrodynamical modeling, you can utilize for others purpose, as I mentioned before. Yes, you can use the hydrological and hydrodynamical modeling for the flood event, to simulate the flood event. But again, you can simulate for the water supply. You want to see whether the water is enough or not. So that's the function that can be utilized in the hydrological and hydrodynamic modelings. So for the hydrological, so this is the IDFA curve that I mentioned before, you guys. So this is the IDF that we abstract from the MASMA or from the hydrological procedures number 1, which is to estimate the rainfall. So this is the pattern of the IDF curve. And then so this is the hydrological modeling. So for me, I like to using the HMS to simulate the runoff or the discharge. So in the HMS, actually the process of how the rainfall convert to the runoff, we can formulate in this software. So it's a very powerful software, and you guys can obtain and download freely, and everyone can be used the HMS. And as you can see, if you guys really familiar with the hydrological modeling, so this is the catchment that we delineate, and downstream here there is a reservoir. So those who are from police, most of the time they will know this is the subcatchment that present the upstream of Timah Tasuh. So yang bawah ni Timah Tasuh punya empangan lah di Matasoh Reservoir. And then the second thing, we have the hydrodynamical modeling. So this hydrodynamical modeling, or sometimes people like to use the term hydraulics. So this model, actually we want to estimate the water level. So nowadays there is a lot of the model just not simulate for the 1D, but we able to simulate up to 3D simulation. So the most popular model that you guys can use is HEC-RAS. Okay, HEC-RAS, I think the next section, if I'm not mistaken, I'm not sure whether because the next section is 16 July. Okay, you guys will be introduced with the 2D modeling and also the hydraulics and flood modeling. So normally for the open source, you guys can using the HEC-RAS. It's open source from the US Army. And then we have package like Mark 11, and then the diagram that I show you guys actually is from the InfoWorks. So this catchment from, I think, from Kuala Lumpur. This one, because this layout actually I obtained from the from IR Abdul Jalil. So this one produced by the InfoWorks. Okay, we have another software like My 11s. They're able to simulate the flood modeling. So HMS and HEC-RAS. Okay, HMS for the hydrological and HEC-RAS for the hydrodynamic modeling. But for the InfoWorks and My 11, they integrate two. Okay, that's mean they able to do the hydrological modeling and as well to do the hydrodynamic modeling. So 2 in 1. So it's more comprehensive. And for the InfoWorks and My 11, okay, you need to buy the license, and it's very pricey. But the advantage of this two software, which is InfoWorks and My 11, is very comprehensive software, and their interface and quite easy to run. But for the HMS and HEC-RAS, that's one you need to use individual. If you want to simulate the hydrological modeling, okay, you need to using the HMS. And for the hydrodynamic modeling, you can using the HEC-RAS. In some cases, for the hydrological modeling, some they using the rational method. Okay, probably you can using the Excel, okay, to simulate the hydrological modeling. So we have a few methods that you can directly calculate, such as rational method. We have time series method. So so it's depend on you guys whether which one that you want to use. After you do the hydrodynamical modeling, so you can know the inundations areas, and then after that you able to produce the hazard maps, and lastly you guys able to produce the risk map. So before you guys go on estimation the rainfall or design the rainfall, okay, you need to know this term, which is the average recurrent interval, or we call as ARI. So ARI actually is a common criteria used when you study the hydrology and hydraulics facilities. When you want to design the thing that related with the water, okay, you using this term. Okay, So ARI basically is the set based on the wildlife economy of facility, the level of protection required, and the hazard potential to the downstream area. So ARI. If we compare hydrology and hydraulic system, ARI, we can compare with the service life in structure. Okay, betul. Kalau structure, when you want to construct a building, okay, you guys use service life to represent the service life of the structure. Contoh 100 tahun service life. Okay, so this concept actually is same thing for the ARI. Okay, for example, you have 100 ARI, or not, or we call as 100 years ARI. So there is a probability the event occurs in one time in 100 years. Okay, 1%. Okay, dia tak semestinya dalam 100 tahun tu takkan terjadi. Okay, mungkin akan jadi 2-3 kali. It depend. But in the easy understanding, we can say, okay, this event will be occur in 1 year over 100 for 100 years ARI. Okay, so dia sama macam 100 years ARI is equal to 1 over 100 of possibility. Okay, it's the same thing. So high ARI, actually we can relate with the high risk. So for the most mega structure, for example reservoir, okay, you need to design the very high ARI. For example, 100 years ARI, 500 years ARI. This one for the mega structures. But for the small structures, for example, for the drain perimeter drain, okay, longkang-longkang tepi rumah, okay, normally we design for the low ARI. Okay, for example, probably 3 months until 2 years ARI. So if you have the high ARI, that means it will increase the high cost. So the selection of the ARI actually based on the importance of structure. Kalau structure tu very important, okay, and then its effect a lot of people, okay, normally we design up to 100, we have the high ARI. And then we select based on the cost, level of protection, and impact of the failure. So as you can see in this table, so for the swell or small drainage, okay, swell ni macam dia macam longkang tau, tapi normally longkang we using the concrete, okay, the line of the drain normally is concrete, but the swell diorang tanam rumput lah, diorang tanam rumput, and then dekat bawah at the bottom of the swell tu they put some what we call that, dia letak macam jaring-jaring. So swell ni agak bagus lah. And normally if we study the urban stormwater management, so swell most become a preferred drainage to be used to replace the concrete drain. So that's the swell. So most of the time for the swell or small drainage, we design 2 until 5 years. For the stormwater drainage, okay, you design up to 2 until 25 years. Okay, 25 years. Okay, and then sometimes for the monsoon drain, kan monsoon drain kalau you tengok dekat tepi-tepi jalan yang longkang yang besar-besar tu, okay, kadang-kadang dia orang design up to 50 years, and then ada case sampai 100 years ARI pun ada. Because as I mentioned before, mungkin dekat kawasan situ, okay, kawasan yang berpendapatan yang mempunyai populasi yang tinggi, kawasan yang padat. So and then dekat situ ada kawasan commercialized area. So kalau banjir, banyak people that will have affect and boleh menyebabkan kerugian yang agak-agak banyak lah. Kalau contoh KLCC tenggelam kan, you can imagine lah what the effect. So that's why they have nearby for that area. Normally their level protection of the structure normally up, the ARI quite high. Okay, and then for the retention pond, okay, retention pond tu something like detention pond yang simpan air bila masa hujan. Okay, bila hujan turun, normally the excess water, okay, we go to the retention pond, and this pond will hold the water, okay, until certain up of the ARI. So the reason because they want to protect the area at the downstream of the pond. Kalau tiba-tiba dekat upstream, okay, catchment tu tinggi air sungai, so bila kat bawah boleh menyebabkan banjir. So that's why they put the detention pond, okay, to hold the water. So bila sampai satu tahap, bila hujan berhenti, and then detention pond tu penuh, barulah lebihan tu akan keluar, okay, secara perlahan ke dalam ke downstream. So kawasan downstream tu tak banjir lah. And then we have a reservoir. So reservoir normally their ARI is around 500 to 1000 years ARI. That's one for the small reservoir. But for the large reservoir, for example for the Klang gates, okay, normally they design up to 10,000 years ARI. Okay, and then sometimes we call as a PMP. PMP. So PMP, you guys will learn after this what the meaning of the PMP. So in hydrology, if we want to estimate the ARI, okay, you guys can see the MASMA 2. Okay, in MASMA 2 in chapter 1, I think the chapter we name as design criteria. So there is a table in chapter 1 in MASMA 2. So here they have classified the development, okay, based on the residential, and then you have bungalow, you have link house, up to the institution and building complex. So you can see there is a minor system, and then you have a major systems. So when you want to design the hydraulic infrastructure, so normally we need to design based on two systems, minor system and major system. Okay, minor system, that means you want to design the structure that able to tackle the rainfall that frequent happen. Maksudnya hujan yang selalu berlaku, contoh 20 mm per hour. So normally their ARI is around less than 5 years. So that's one we call as a minor system. But for the major system, okay, you have probably, for example here, for the residential, you have 50 years ARI. Okay, that's mean you punya drain, okay, akan jadi besar, 50 untuk tackle 50 tahun ARI. So we need to have two component. You tak boleh ada salah satu. Maksudnya you tak boleh design untuk satu sistem saja. Sebab bila hujan yang lebat, okay, ada sistem yang lain we call as a major system, they able to cater the heavy rainfalls. So tak adalah berlakunya masalah banjir. So as you can see, this one you have on-site level. So you can see on-site level tu macam rumah you. Okay, rumah you, your small resident, your punya rumah, okay, For example, macam rumah you lah. Kalau rumah you normally untuk drainage systems, okay, you guna for the less than 10 years ARI, because you want to tackle the problem over your punya resident area. So you tak ada design longkang yang besar-besar. Longkang yang kat rumah you tu semua kecil-kecil. Sebab apa? Sebab you nak tackle the rainfall yang berlaku dekat kawasan rumah you. Tapi untuk community level, okay, community level something at the large area. Contoh rumah you, and then mungkin ada taman. So satu taman tu, okay, for example dia hydraulic facilities. Contohnya macam detention pond. So dia nak kena design up to 100 years ARI. So barulah air yang mengalir, okay, dia tak melimpah dan boleh menyebabkan satu kawasan taman tu banjir. Okay, so this is the example of the hydraulic structures that available, and you guys can see. For example, detention pond, so you have the channel or drainage, and then you have a gross pollutant trap. Gross pollutant trap, this one for the environment, because you need to bear in your mind, if you want to control the flow, okay, you do not control the quantity of the flow in terms of the peak discharge, okay, you also need to control the quality of the water, okay, in terms of the pollutant. So pollutant contoh macam gross pollutant macam sampah sarap, okay, you kena tapiskan dia, okay, dekat you punya downstream sungai supaya tak masuklah ke dalam sungai besar. Bila benda ni terjadi, bila dekat kawasan small area kan, contoh you tak control water quality, okay, and then sampah tu masuk ke dalam sungai besar, and then bila sungai besar tu masuk and then lepas tu sampah-sampah tu mengalir ke laut. Itu kalau sampah tu mengalir, kadang-kadang sampah tu yang menyebabkan banjir, okay, di mana sampah-sampah tu tersekat dekat kawasan longkang, kan, kawasan-kawasan yang mempunyai outlet yang kecil. So bila longkang tersumbat, kawasan jadilah banjir kilat. So that's the common thing lah occurs nowadays. Okay, a lot of people complain about the flash flood, especially on the urban area. Dia kata GPS tak buat kerja, majlis tak buat kerja, bina all drainage system lah. Bila we go on that side, okay, kita tengok longkang, Masya Allah, penuh dengan sampah sarap, walaupun that area have been frequent being maintained. Maksudnya selalu syarikat sampah pergi kat situ kemas longkang-longkang, tapi lepas seminggu 2 minggu penuh. Belum kita cakap lagi illegal punya connection. So you know, that's the problem that occur nowadays, especially kat Malaysia lah. People not really helping the authorities, okay, to overcome this problem, the flood problem. Okay, dia kata kalau lah apa berlaku, salah GPS dah, salah majlis. Tapi sebenarnya mentaliti masyarakat yang buang sampah sarap sehingga menyebabkan longkang tersumbat dan menyebabkan banjir. Okay, so this is the example of the detention pond. Okay, why I show you guys this one? Because when you have the detention pond, okay, that's mean you need to consider these two systems, minor and major systems. Okay, you cannot say, okay, you want to design for the major system, Okay, kalau you design major system saja, okay, so you punya kawasan you tu macam tak very effective. Okay, that's mean if you have the detention pond is not very effective. Dia akan lama-lama, okay, sebab you design tu untuk high ARI. Bila air masuk je, kan, bila hujan biasa je, air tu berderu terus masuk ke dalam sungai. Tapi kalau if you have the minor system, at least you punya detention pond tu dia boleh hold the water, okay, for the low RI. And then if that detention pond face the heavy rainfall, which is the high RI, so that detention pond able to function very well. So this is the outlet. So you can see they have orifice, and then there is a broadcaster weir, and both systems have been designed based on the minor and also for the major system. Kalau kita tengok orifice ni, saya rasa ini 50 tahun ARI ni, sebab dia besar kan. And then untuk broadcaster weir ni, actually their function is for the spillway. That's mean kalau ada air lebihan, maksudnya bila air terlampau tinggi, okay, air tu akan masuk ke dalam spillway, ke broadcaster weir yang bertindak sebagai spillway. So tak adalah you punya detention pond to fail. Okay, so for the clung gates, how many RI to design? So you nak design 10 tahun, 100 tahun ke? You nak design untuk 10,000 tahun ke? So suppose this one for the clung gates, or for the heavy, for the what we call that, the mega hydraulic structure, like reservoir, like clung gate dam. Okay, normally they design up to PMP, probable maximum precipitations. And I think after this we will go through on how the calculation of the PMP. Okay, ada orang kata PMP ni is equal to 10,000 years RI. Ada setengah kata nilai PMP tu lebih dalam 50,000, ada kata 100,000 years RI. Okay, so there is no exactly value. So we know when we design some certain of the mega structures, we know the final return period, actually their limit is a PMP, the most maximum one. Okay, so that's about the ARI, average recurrent interval. We go to the rainfall distribution over Malaysia. Okay, baru kita nak masuk apa itu rainfall, macam mana you nak dapatkan, nak estimate the rainfall intensity. Okay, so in Malaysia, the characteristic of the rainfall actually is high in terms of the frequency and the intensity, but short durations. Okay, that's mean kalau hujan, okay, hujan dekat Malaysia biasanya singkat, tapi dia banyak dan intensity yang tinggi. So that's the characteristic of the rainfall in Malaysia. So the annual rainfall in Malaysia is around 2,500 mm. Okay, it's quite high. High rainfall is occur during the inter-monsoon. But for the East Peninsula and East Malaysia, okay, normally the heavy rainfall occur during the northeast monsoon during November and March. So normally the rainfall occurs in the late afternoon and also in the early evening. That's why sekarang kalau you perasan pun cuaca kan, pagi waktu siang lah, waktu siang tu panas hangat, especially siapa yang duduk dekat Perlis macam saya kan, memang panas sangat lah kan. Saya tak pastilah dengan negeri lain, tapi dulu saya sebenarnya berasal daripada Melaka. Saya tak rasa cuaca kat Melaka panas tau. Tapi bila saya pindah dekat Perlis, cuaca sangat-sangat panas dan rasa terik. Kadang-kadang saya terpaksa on aircon kan, macam almost kalau duduk rumah tu daripada pagi dah buka aircon dah, sebab dalam pukul 11 tu dia dah mula terik lah. That happen dekat Perlis. Tapi kalau dulu kat Melaka saya rasa tak pernah saya rasa macam ni. Itu ramai orang kata kat Perlis ni memang cuaca hangat sikit lah kan. So lama saya dekat Perlis lagi hitam lah lepas ni kan. Okay. So jom kita kembali balik ke slide kita. So normally rainfall occurs in the late afternoon and early evening. That's why during the morning and also evening tu, afternoon, sangat panas, and then suddenly masa evening or during the night there is a rainfall. So that's the characteristic of the rainfall in Malaysia. So the problem with the intense short duration rainfall, actually it causes flash flood, mainly in the main city. That's the problem. But I think this statement, saya tak pastilah, this statement saya ambil daripada buku mana. I think currently this is not become an issue, because I think JPS, Jabatan Pengairan dan Sediran, and then JKR also doing a good part, dalam melihat isu-isu banjir ni. Kalau JPS, banyak juga longkang-longkang yang di kawasan yang selalu banjir kilat, telah di-upgrade. Dan jaranglah kita dengar masalah banjir kilat ni berlaku. Tapi bila saya tengok dekat televisyen, macam kawasan KL tu agak teruk jugalah. Nowadays lah, saya tak pasti nowadays. Probably due to climate change, like our topic. But I can see area like KL still the flash flood is occur, but not very frequent. And then the most wet in Peninsula actually at Taiping. Banyak orang kata kalau ada one of my friends, dia selalu berulang-alik daripada KL ke Penang. Sebab dia ada company dekat Penang, and then a lot of time dia perlu ke Kuala Lumpur lah untuk hadir meeting semua. So bila dekat highway sampai kawasan Taiping je, dia kata selalu hujan. So dia nampak lah this pattern. And then I think his assumption actually is correct lah, because this statement said the most wet area in Peninsula is Taiping. And then the driest in Peninsula is Kuala Pilah, Negeri Sembilan. And then the daily temperature is 25 to 33 degrees Celsius. So that's one. If you ask me which area that facing that the most wet in Malaysia, I think in Sabah, I think kawasan yang paling lembap, di Sabah. So we Malaysia, we face two monsoon. The first monsoon is a southwest monsoon, and then the second monsoon is a northeast monsoon. So normally for the southwest monsoon, we don't have any issue. Rasa tak jarang lah kita dengar banjir besar berlaku during this monsoon. Because you can see we have Sumatra who has saved us okay, most of the heavy rainfall that bring by the monsoon, okay, will be shielded by the Sumatra, and then most of the area along Sumatra here, okay, will facing a high intensity of rainfall. So bila sampai ke Malaysia, okay, angin pun dah kering lah. Tak sempat dia nak serap air daripada laut. But this monsoon, northeast monsoon, normally during this time, okay, area like Kelantan, Terengganu, and also Johor. If we talk about the West Malaysia, okay, Sabah and Sarawak, okay, during this time they are facing they receive the heavy rainfall, okay, because during this monsoon you can see, okay, tengah-tengah ni laut. So most of the time, okay, angin yang bawa monsoon ni dia akan air akan evaporate, air laut akan evaporate dan jadi awan, dan angin monsoon ni membawa awan yang bawa awan yang mempunyai air banyak lah. That's why, so the first area dia akan jumpa Kelantan dengan Terengganu dengan Pahang. That's why kawasan situ akan terima hujan yang lebat. Okay, and then I think semua orang pun dah tahulah, during this monsoon, okay, the coastal area, the east coast area we facing the floods. Okay, sama ada banjir tu teruk ataupun tak. Tapi banjir tu pasti akan berlaku dekat kawasan seperti Kelantan dan Terengganu. So this is some studies that conduct by my student. Betul lah, during the northeast monsoon, the east coastal of the peninsular Malaysia will receive a high intense of the rainfall. But during the southwest monsoon, you tengok banyak spot yang kering. Kalau yang putih ni maksudnya jumlah kekerapan hujan yang rendah. Tengok macam kawasan di seorang kawasan Perak, di seorang kawasan Selangor. Ni yang tadi kata Kuala Pilah tu, memang betul lah Kuala Pilah. Tengah-tengah ni Kuala Pilah mengalami menerima taburan hujan yang agak sikit lah untuk kedua-dua monsun.